Hello, this is a video about making guitar pedals. So if you were ever curious about how to get started and how to make your own guitar pedal, I'm going to walk through the whole process, and not in great detail, but pretty much hit all the points from the original idea, finding a schematic, working with the schematic, and creating a circuit board, and then soldering all the parts and putting it all in the box. So oftentimes I get started by looking at websites like freestompboxes.org. There's a whole bunch of sites out there that have layouts and schematics and things that you can draw ideas from. I like this site. This is a great place where people discuss stomp boxes, and they have several different sub forums like vintage stomp boxes, modern stomp boxes, boutique stomp boxes, and then this DIY section, which is all ideas that are sourced from the community, right? I was browsing through this page or this sub forum here, and I came across this schematic, right? This is a version of the Big Muff by this user Mike Tester. And I've built a couple projects that Mike Tester has posted in the past, and they all worked really well. And so I found this one, and I thought I would give it a try, right? So what is this? This is a Big Muff with a treble and bass tone control. It's basically called the James Tone Stack. And the James Tone Stack was a tone control that was used on orange amplifiers, right? Where they have a bass and treble control, right? With no mid control, right? He says that the tone control goes from a mid scoop when you turn the bass and treble all the way up to flat with the controls about halfway, to a mid hump like a tube screamer with the controls down a bit. Okay. So let's take a look, right? So let's look at the schematic really quick, right? I'm going to go back to the schematic. There's a picture of it up there, but this is kind of a better picture right here. So basically this is the Big Muff, right? So if we look at the 3 transistors here in the middle, this came directly out of the standard Big Muff. Now the Big Muff, there's lots of versions of it where the values change, but the schematic here, the way these parts are arranged, doesn't change. It's the same for almost every Big Muff, okay? What Mike Tester has done is added a JFET transistor on the input in front of the first transistor. And this is to fix a problem that doesn't really seem to be a problem with the Big Muff, but if we look at the Big Muff, technically, it has a low input impedance, or lower than we would like for guitar pedals. Like with the guitar pedals, we'd like to have a 1 mega ohm input impedance. Otherwise, you tend to lose highs, and maybe this pedal doesn't play well with pedals that come before it. So here, with this JFET input, we get a 1 meg or higher input impedance, okay? Right, and then after that, everything is the same. The other thing that Mike Tester has done is up until this point, everything is the same. After that, we've made a couple changes here, right? So one, that the last transistor here is a JFET transistor instead of a BJT transistor, okay? And this transistor is used to make up the loss of volume from the tone stack, right? So basically the tone stack is shaping the tone, right? But there's a cost there, and the cost is volume. So we lose some output, but we get to change change the frequency response, right? But to make up for that change in output, we've added a transistor on the end to boost that. And the regular Big Muff does this, but it uses a BJT type transistor, and Mike Tester's used a JFET transistor here, okay? The other change is the standard Big Muff has a single tone control that sweeps from bass to treble. And here we have a tone stack with a bass control and a treble control. And so we can adjust each separately, okay? So this James Tone Stack, let's investigate that for a minute, right? So what I did is I looked it up on the internet, and you'll see here's sort of a picture of the standard schematic. There's a few of these here, right? And you'll notice that on the James Tone Stack, there's a single capacitor here and here, right? So I can see there's one capacitor there and there, and otherwise this is all the same. Now, the thing to know here is that these two capacitors in series if they have equal value, they act as a capacitor half their size. Okay, so this, instead of being a 1N capacitor, is going to be a 0.5N, so it'll be half the size, right? If they were in parallel, they would add together. So this follows the same rule as series and parallel diodes, or not diodes, but resistors, but it's the opposite. Okay, so where series resistors add up and parallel resistors use the parallel resistor formula, series capacitors use the parallel resistor formula to calculate their value, right? But the quick way to calculate it is if the two values are the same, it's half the value. Okay. So this one's going to be a 500 picofarad or 0.5N, and this is going to be a 5N capacitor, right? So let's take a look at that here. I Googled and I found the tone stack calculator, right? So this is a website that, here's our James tone stack right there, and it allows us to kind of view the frequency response over here, right? And it does a whole bunch of different tone stacks. So here's the standard Big Muff tone stack, and here's the James tone stack, right? And then they have there's a couple different versions. So there's a dual base capacitor and single base capacitor. And basically the difference there is there's these two capacitors here. This is the two capacitor version, and the single one has one capacitor that kind of jumps across these two and doesn't connect in the middle there. Okay. But anyway, I took the values from Mic Tester and I plugged them in here, right? And I set the pots to log rhythmic, right? And you can see when I turn turn the pots all the way up, then I get a pretty good mid scoop here. And when I bring them down, I have to bring them way down. He said it about in the middle, but in the middle, I'm still getting a pretty good mid scoop. But when I get to about here, I'm getting a pretty flat response, right? So this is about the flat response there. And then if I go all the way down here, I start to get the mid hump. Okay, so there's my mid hump there. So I feel like maybe instead of the A taper pot, if we use the C taper, it might fix that. I don't know. Anyway, we'll get to that later. But they don't have an option for that, or we could test it out here, right? Either that, or maybe we could wire the pot backwards. Anyway, I don't know. But anyway, so one other thing to know about the tone stack here is that in this mode right here, this is 0 dB and this is -40, right? So we're losing a lot of volume here. So that's what that last transistor is going to make up for, right? So this is going to be -30, this is -42, right? So as we change the tone control, we may also have to adjust the volume, right? And then when we get to here, you can see we're maybe 0 dB at these extreme frequencies, but we're still -22 dB in the middle there, right? So anyway, so that's what that last transistor is there for, right? This is there to bring up the volume that we lose going through the tone stack. So anyway, so in the next section of the video, we will take a look at the PCB and we'll solder all the parts and talk about how to assemble it. This is the PCB I had manufactured at PCBWay. You can see it looks, very similar to the design created in Eagle. So the first step is to solder all of the resistors. Now, why are we starting with the resistors? Well, the resistors are the lowest part. They're not as tall as the other parts. So it's easier for us to solder the parts that are, shorter and then work our way to the taller parts. This board was designed for 1/8 watt resistors. A lot of resistors are 1/4 watt and they're a little bit bigger, and there'll be a picture of one of those coming up, but you can see this resistor is pretty small and the footprint of the resistor matches the size that I have on the PCB. Okay, now I'm going to match the parts to the values on the board, right? So the board is marked with part numbers and I'm matching that to the value of the parts on the schematic. Usually what I do is I solder a group of resistors at a time. So here at the bottom of the board, you can see that there's 4 resistors in a row, and so I'll populate those on the board, and then I'll solder those 4, and then I'll go on and do the next group. After soldering the resistors, I clip off the leads on the back and then move on to the next group of resistors. Here's the board with all the resistors soldered. A couple points. Notice all the resistors are lowest on the board, like we said earlier, so we want to solder the low parts first. There's one that is a 1/4 watt resistor, and I had to bend it at kind of an angle and make it stand up, but that's okay. It'll work just the same as the 1/8 watt resistors. Next, we'll solder the diodes. It's important to understand that diodes all have a stripe on one side. So we need to make sure that that stripe goes in the hole on the PCB with the matching stripe. You can see it in the picture. This PCB also has square pads where the stripe is. Okay, so we'll bend the leads at 90 degrees, and the diode will go into the board like this with the stripe on the right side. Next is the 1N914 diodes. These are small glass diodes, and they have a black stripe, right? And the stripe again matches the stripe on the PCB. So there's 4 of them here. Note where the stripe is on the PCB, and you can see the square pad. Okay, so here's the board so far. You can see all the diodes and the resistors are all pretty low-lying parts. Now we're going to move on to some taller parts. Next is the 100K trim pot. So we'll get one of these out of the bag here and put it in the board. Next, we'll move on to capacitors, okay? So capacitors are marked with a value, and the value is 3 digits. The first 2 digits are the value, and the third digit is the number of zeros. So it's hard to see here, but this is a 560 picofarad capacitor. So the value shown on the part is 561. So that's a 5 and 6 and then 1 0, 560. Again, I follow the same procedure. I solder groups of capacitors together at the same time and then move on to the next group. This is a 100 nanofarad capacitor. It's a 1, a 0, and then the 4 is 4 zeros. So that's 100,000 picofarads. This is a 47 nanofarad capacitor. The value on this is printed as 47N. These box capacitors use a different system for printing the value. This is an electrolytic capacitor, and these have the value printed on the side. You can see it here. So this should be 100 UF at 25 volts. These are polarized. They have a positive leg, which is the long leg, and a negative leg, which is the shorter leg, right? And then the shorter side has a stripe on it with a minus sign, okay? So you can identify that. When it goes into the board, the positive leg has to go into the square pad, and there's a little plus sign on the pad above the square hole, and then the short leg goes in the round hole. Okay, so here we are. We've got the board. It's got all the resistors, the diodes, the capacitors, and the trim pot all in place. Okay, so next we need to solder the transistors. Transistors 1 and 5 are JFETs, and they're using a 2N3819 transistor. You can see the part number is very small, but it's on the side of the part here, and you can read it on the part. Here's another part. This one says 2N3 on the first line and then 819 on the second line. So that's the part number. This is the multifunction tester TC1. I got this on Amazon for about 20 bucks. It's great. It tests all sorts of parts. We can test the transistors with this. You basically put a leg in each of the holes and then press the button, and then it'll tell us what the source, drain, and gate are, right? And it tells us the leg number. So leg number 1, 2, and 3, and those match up to the numbers where the part was plugged into the tester. Okay, the footprint of the transistor has a round side and there's a flat side on it, okay? So we need to make sure that the shape of the part matches the footprint and that the legs go in the right holes, right? So you can see I'm placing the part in there, and then the flat face of the transistor body is facing the flat side of the outline that's printed on the PCB. The other three transistors are 2N5088 type. So you can see here that, again, the part number is printed on the side of the package. So you can read here it says 2N and then 5088 underneath it. Hey, let's test these transistors with the multifunction tester. These are BJTs, so they should have an emitter, a base, and a collector. And then the multifunction tester is telling us what number each of those pins are. Since these are the parts that match the parts that were spec'd in the project, they should match the shape on the PCB. So again, the flat side on the outline will match the flat side of the actual part. And there we go. We got all the parts in the board. There's a couple parts that are missing, and these are the pots and the LED. We're going to save these for later, and we're going to solder them in after we put the whole thing in the box. And this will allow us to make sure everything is square to the box and that the LED aligns with the hole in the box. Okay, so the LED has a long leg and a short leg. And then if you look really closely, this small LED, it's hard to see, but if you look really closely, there'll be a flat side on the LED, and the flat side should be on the same side as the short leg, okay? So the long leg is going to go into the square pad on the PCB, and the flat side is the short leg, and it goes into the round hole. So there you can just barely see the flat side on the LED, short leg. The LED and the pots will be soldered onto the back of the board. Okay, so not on the front of the board. We're going to flip the board over and we're going to put this in the back side. Okay, so this goes on the back here. Remember, the long leg goes in the square hole or the square pad. And then we're going to add the pots. The pots all have a value printed on them. So here are the pots that I have. And if we look closely at the pots, there will be a value. It'll be on the back, and it also shows on the front. So there's an A100K pot. That's audio taper 100K. And you can see on the top, it shows the value again. Okay, so here we have an A500K pot and an A1 meg pot and another A100K. Okay, so here's the enclosure, and we're going to fit the parts into the enclosure. The LED is going to fit the hole in the center there, but it'll come in from the back side, right? And then the pots and the LED are drilled so they match the locations on the PCB. The next step is to place all of the pots on the board, and we're going to fit them to the board but without soldering. Okay, so we'll solder them later. We're basically going to put them into the board and then put everything into the box and put the nuts and washers on and then solder it. And this will guarantee that all the pots are in the correct location. We'll do the same thing with the LED. So we'll fit the LED to the board without soldering it, and then we'll position it into the enclosure so it pokes through the hole, and then we'll solder it, okay? Remember, we need to position the LED so the long leg goes in the square hole. Turns out the holes were too small, so what I'm going to do here is I'm going to use a reamer to make the holes a little bit bigger so they fit the pots, right? So they were a little too small. So the reamer, I got this at the hardware store for like 10 bucks, and it works great, you know? Now I've got all the parts on the board without soldering, all the pots, and now I'll fit the whole thing into the box. Sometimes you have to bend things so they kind of line up correctly, right? So I'll do that. I'll fit it all in the box here, and then I'm going to put the washers and nuts on to hold it all in place. Now I'm going to maneuver the LED so it pokes through the hole in the PCB, right? So I'll align it from the back side, and when I've got it poking through the front, then I can flip everything over and start soldering. Okay, so now I can take the nuts off and pull the PCB out of the enclosure. You know, we could have left the whole thing in there too if we were ready, but I actually need to drill a couple more holes in this box. But you can see now, as I pull everything out, all the pots are in exactly the right location. The LED is the correct height and will line up with the hole in the enclosure, right? Okay, so everything aligns there, and then we're all ready to assemble.